Hello guys, this is Raghav, and in this video I'm going to discuss with you some of the most commonly faced issues in Kubernetes. What do they mean? Why do they occur? And how do you troubleshoot them much faster using artificial intelligence? Oftentimes, the first symptom that something is wrong with your Kubernetes application is that one or more of your pods refuses to start or crashes after starting. And typically during such issues, you and I would start digging deeper into the problem. We would run kubectl describe to get detailed information, check the pod logs or examine the manifests to see if there's any problem, determine if our pod has enough resources to be able to function properly, and all those things. But now we have tools that are a lot more powerful thanks to large language models or LLMs. AI tools can automatically troubleshoot all our problems, determine the root causes, and even in many cases suggest the right fixes to apply. So today I'm going to show you how you can use AI to troubleshoot errors in pods and even Prometheus alerts much faster without you having to do anything. Let's get started. I'm going to start with one of the easiest yet very commonly faced issues. At the moment, I'm trying to run one pod in my namespace, but as you can see, it's currently failing with something called ImagePullBackoff. This often starts with something called ErrImagePull and then converts into ImagePullBackoff. And what that means is that the worker node on which this pod is being scheduled, that worker node is unable to pull the image of the container that we are trying to run as part of the pod. So ImagePullBackoff means that the pod tried multiple times to pull the image so that it can run the container, but it failed each time. And so ultimately we are at an ImagePullBackoff. So let's debug this issue. First, I'm going to try and manually debug this, which is also what we traditionally do. If I try to get the logs of this pod, I won't actually get anything because the pod hasn't started yet. So nothing was running and so there are no logs produced. But yeah, I do get the confirmation that the payments container was indeed not running because it failed to pull the image. Okay, then let me try to describe this pod. Yep, ErrImagePull, ImagePullBackoff. And so there is one error message right here, which is telling me exactly what's going on. Pull access was denied. So when the pod tried to pull payments app container, the access was denied to it. And that's because either the repository does not exist, or if it exists, we currently don't have the authentication or authorization to pull this image. And these are mainly the two reasons because of which you get ErrImagePull and ImagePullBackoff errors. So it is possible that you made a typo in your pod spec. And so because of that typo, maybe instead of saying payments app, you just said payment-app. And so that container doesn't actually exist. That repository doesn't actually exist. The other reason is that the image you specified is in a private registry and kubelet doesn't have enough authentication and authorization to pull that image. So since my image is duaragavate/payments app, in my case, I know that this image does exist, this repository does exist, and the image also exists inside it. But the important part is that this registry, this particular repository is a private one, right? So that means I haven't given the proper authentication to kubelet so that it can pull the image. So it was pretty easy for me to find the root cause here, but I'm sure you know that production scenarios are almost never as easy as this one. Often it can take hours or even days to dig down to the root cause, and it becomes very, very frustrating. During an outage or an incident, you can't even afford to debug for hours. So now let's debug this issue with the help of an AI instead, which will be a lot faster and a lot less frustrating for us. I'm going to use a tool called HolmesGPT. It's an open source tool which acts like an AI assistant for DevOps engineers. Basically, Holmes connects to your infrastructure, talks to an LLM to understand the issue you gave it, and actually performs actions to investigate the whole thing. So it doesn't just give you generic responses like, if your pod is not starting, try this, try that. It actually does those things, digs down deeper, until it has arrived at the root cause based on the specific situation of your Kubernetes cluster. So think of it like another DevOps engineer only. And currently it can do a lot of stuff on its own. I can just point it to my Kubernetes cluster or a PagerDuty incident and Holmes will dig into the issues that I ask from it. The tool itself is free, but know that it connects to an LLM. So depending on what LLM you supply to it, maybe OpenAI's GPT or Llama from Meta, depending on what LLM you supply to it, you might have to incur some cost, right? In my case, I'm going to be using GPT-4o from OpenAI, so I'll have to pay some money for the API access. So be sure to know your costs upfront. For me to create this entire video, it cost me about $3 in total of OpenAI API access. So I suspect that it's going to be very cheap in general. So back to the issue at hand. Now I'm going to ask HolmesGPT to investigate this same issue for me. Now, essentially how it works is you invoke Holmes as a command line tool. You specify the model and specify what APIs you want to talk to. In my case, it's GPT-4o from OpenAI. And you also give it a prompt, right? You can start with a very basic one like I did. I'm just asking Holmes, what exactly is the problem with my pod? Just explain the problem and give me some solutions. But of course, if you know prompt engineering, you know that there is a lot more that goes into a prompt and we will see more of that later. Okay. Cool. So Holmes goes and talks to my LLM. Then it tries to investigate the issue, right? It takes some real actions using the kube control and tries to figure out what the root problem is in my cluster with my pods. And finally, it arrives at the same problem that we saw, right? There is an ImagePullBackoff and we were denied access to the repository and the image inside it, right? So it has suggested some solutions which I think are highly relevant here. Verified that the image name and the tag are correct. We saw that it was correct. And then verify that, the private registry, we have enough authentication and authorization for it. And yeah, before that also that it actually exists, the registry, right? And you haven't misspelled or something like that. And finally, if all of your verification is good, then you need to add the authentication and authorization into your pod specification so that the kubelet can pull the image and start running it as a container. But the answer isn't satisfactory to me yet because I now want to understand how to actually do this step. How do I add the authentication layer for my pod so that it can start pulling the image, right? This is not detailed enough for me and I want a step-by-step instruction on how to do it. So let me now improve my prompt a bit. Cool. This time I'm going to tell Holmes that, yeah, this is my problem. I understand it. But how exactly do I add authentication? Okay. So the solution is roughly 2 steps. One is to create the secret in my Kubernetes cluster and then modify my pod specification to use the secret while pulling the image. Okay. Makes sense. I'm going to create the secret first. I'm going to use my Docker Hub username. For the password, I'm going to use my Docker Hub access token, which has read permissions on my private registry. So let's put this on the side for a while and okay, I have sourced a shell script. This shell script sets the Docker access token in my environment as an environment variable. And I generated the access token from my Docker Hub. So you can easily do that too for your own Docker Hub registry, or depending on what your registry is, you might have different authentication. And this method is much more secure compared to me hard coding the access token in the command or exporting the environment variable myself on the screen. So now let me go back to my command. Okay. Yeah. Looks like my secret is now created. Now I need to tell my pod specification to use this secret while pulling the image so that it can authenticate with my private registry. And the main thing to do is to use image pull secrets. So here's my original pod spec, and I've told my pod that when you're trying to pull this container image, use a particular secret that I've created in the Kubernetes cluster. The secret's name is Docker Hub Access, and you use the credentials as specified in the secret, you're going to be able to authenticate. How about we try deploying the new pod spec now? This. My bad. I need to delete the old pod. Nothing. Let's start again, and perfect. So now my pod is running, which means the root cause and the solution given by Holmes was correct. I added the authentication, I added the secret, and using it, the pod successfully ran. Now there's no more ImagePullBackoff, no more error image pull, because now I'm able to pull my image from my private registry. So this is what error image pull and ImagePullBackoff means, and this is how you solve it. Now keep in mind that there are other ways of authenticating too, depending on your situation. For example, you might be running this same pod inside your AWS EKS, and you might be using ECR as your Docker registry. The great part is, in that situation, if you ran Holmes, it would have investigated based on your situation, given you the right root cause, and also how to solve that. So maybe Holmes would have suggested that you apply an IAM policy on your worker nodes, and they would automatically authenticate with ECR and be able to pull all your images. Cool. So this was a very simple scenario, but now let's move on to a more complex scenario and see exactly how powerful AI can be. So in this scenario, I'm trying to deploy 2 Nginx pods to my cluster using this deployment configuration. Let's apply it. Okay, so it looks like one of my pods got created successfully, but the other one is stuck in pending state. This is pretty weird because I have a total of 3 worker nodes in my Kubernetes cluster. So if there are no authentication issues, like in the last scenario, this should be perfectly all right, and I should be able to run Nginx nodes across my entire Kubernetes cluster. So let me ask Holmes about what's going on now. But this time, I'm not just going to ask it the question of what's wrong with my pods. This time, I'm going to try and craft a better prompt. Because remember that ultimately, your question, along with all the context, is going to an LLM. So the better the prompt you can create for that LLM, the better solutions and root causes you can get. So Okay, so this one is rather detailed and I have asked Holmes to explain every possible corner of my problem and also try to investigate my resources in the cluster, my resource configurations, pod configurations, everything, and then give me like step-by-step instructions on how to verify the problem and then also solutions, everything. Okay, I have a response. Let's unpack it from the start. Looks like we have scheduling issues with our pod. Okay, and the first point says that there is an affinity selector mismatch. In Kubernetes, a node selector can be specified in a pod's configuration, and it's a constraint that the pod should only be scheduled on a specific type of node. For example, you might be running two different types of worker nodes. A general purpose machine for running web applications and compute optimized machines for training ML models. And you want to make sure that Nginx only runs on the general purpose machines. So you will specify a node selector label in Nginx pod configuration. Node selector allows you to specify a label for the node to schedule on. Affinity gives you more granular control on selecting which nodes to run the pods on. So if I look at the node configuration, here is the node selector, and I am telling Kubernetes that only run my Nginx pod on a node which has a label of app ready equals true. Okay, so we have a node selector condition. And so what the first point means is that for this particular condition, Kubernetes was unable to find a proper node for Nginx pod to run on. But that shouldn't be the case because I have 3 nodes. So let's see what the problem is. Now the second point says that there is also a mismatch of anti-affinity rules, right? What it's saying is that check your configuration because you might have a condition which prevents one pod to be on the same node as some other pod, right? And if we look at our configuration, it is actually true. We have an anti-affinity configuration where we are basically specifying that 2 Nginx pods cannot run on the same node. And this makes a lot of sense actually because from a high availability point of view, this is very good. We are running 2 load balancer instances on 2 separate machines so that even if one of the machines crashes, it doesn't mean that my entire load balancer crashes, right? So it's good for high availability. But this still doesn't clarify my problem because, okay, fine. If Kubernetes doesn't want to place both my Nginx pods on one machine, that's fine. I have 3 machines, so it should be able to place my Nginx pod, the second one, on some other machine, right? So there's still more to unpack on this issue. The third point states that one of the nodes has an untolerated taint. Now in Kubernetes, you can mark a worker node as tainted. This means that by default, no new pods will be scheduled on this node. Any existing pods will be drained out and scheduled on some other nodes. Tainting a node is useful when this worker node is part of your cluster, but you don't want this node to take up any workloads. You don't want it to run any workloads because probably you want to take it down. Let's say for maintenance purposes, or let's say you want to upgrade the hardware for this node. So you don't want any pods running onto this. So this means that, okay, I have 3 worker nodes and one of them is tainted with status as pending upgrade. So this node is probably scheduled for some upgrade, which means that my Nginx pods can't be scheduled on this one node. Oh, all right. So one of the nodes is out of question. It can't run Nginx, but other than this, I still have 2 more nodes, right? And I have 2 pods to run. So the mystery is not fully solved yet because despite the node selector and despite the anti-affinity rule, I still have enough nodes to run all my Nginx pods, right? These are my nodes. I think yep. So staging 03 has a taint on it with a status of pending upgrade, right? Therefore, nothing can be scheduled on it. but I still have staging 02 and 04. So I wanted to run 2 pods. One is running. Okay, the pod that's running successfully is running on staging M02, this one right here, right? And as I can see, it also has the selector of app ready true. The failing pod, this one, cannot be placed on staging number 2. Why? Because of anti-affinity rules. Fine, that's fair. It can't be placed on 3 also. Why? Because it's tainted. Also fair. What about staging 4? This is then the perfect candidate, right? So let's try to verify whether this is a valid node for my pod to run or not. Bingo. As you can see, for staging 04, the label app ready equals false. And my node selector condition says the app ready label should be true. So 02 was not good because there's already a pod running, 03 was tainted, and 04 does not satisfy the node selector criteria. Therefore, none of these nodes were actually suitable, and that's why my pod is stuck in the pending state. And if you see, that's actually the first verification step that Holmes suggests. That run this to check all your nodes, check the labels on them, and by seeing these labels, we actually figured out that none of the nodes are further suitable for my second pod. And thanks to Holmes, we now understand the root cause of this problem. And we can apply a couple of solutions here. The best solution is to add one more worker node with label app ready equals true. Then Kubernetes can place the second pod because a suitable node is now present. Alternatively, we can also update the node selector. But in my opinion, that's not the best thing to do because we already know why we use this constraint in the first place. So don't remove the node selector constraint from your pod specification. Another good solution is to add a toleration to the pod. Toleration lets you run your pod on a tainted node. It is useful when, for example, you want to run a low priority pod and it is okay if this pod suddenly crashes, but it's more important to start running it. Adding toleration will immediately place the pod onto the tainted node. Now, one thing that Holmes also suggests is to adjust the anti-affinity rules, but this is something I don't agree with because we know why we put the anti-affinity rules there so that no 2 Nginx pods can be on the same host, right? And I want to stick by it. I don't want to adjust that for high availability purposes. So I don't actually agree with this solution that the AI gave. So these are the few things that are possible. Now, just to show you that this is in fact the root cause, that currently we don't have any suitable nodes to run my second pod on. Just to show you that, what I'm going to do is I'm going to change the label on the 4th node and set the app ready to true so that it becomes a suitable node for my second pod. I want to change this to true. Pretty equals true. And on the side, I want to check the status of my pods. Currently, one is pending. Now I'm going to change the label to true. And there. The moment I set the label to true, staging 04 node became suitable for my Nginx pod to run. And now my Nginx pod is about to run. It got scheduled successfully. Yep, there you go. So in summary, I had 3 worker nodes, but only one of them had app ready label equals true and was not tainted. So only one of them was actually suitable for my Nginx pods to run. And because of anti-affinity rules, both my pods could not be placed on the same node. Therefore, the second pod was stuck in pending. So the solutions Holmes is suggesting are quite relevant to my situation, quite optimal, but all of them are not the best ones. But I do expect this to improve over time. The important thing is that it helped me identify the root cause very, very quickly. And so that is mind-blowing. Holmes was able to dig deep into my cluster using an LLM to figure out exactly what my problems are. It understood my context very well, which is something that LLMs by themselves cannot do very easily. I mean, it was smart enough to figure out that there is a problem in my cluster and with my pods related to anti-affinity node selectors and taints. It told me how to verify this issue, and all of this happened within a matter of seconds. And honestly, even if I didn't understand these concepts up front, right, I still had a solution. I still had a root cause. And I also now know what concepts I need to learn in order to understand what the root cause is. That is how powerful this tool is. So it's pretty mind-blowing, it's pretty insane, and it can help me troubleshoot Kubernetes problems much, much faster. Now, let's move on to our third scenario. So in this scenario, I tried to deploy my application pod to my Kubernetes cluster and got an alert in my Prometheus deployment called kube pod crash looping. This basically indicates that your pod is going through something called CrashloopBackoff. So here's my application pod, and I know that it is going through something called CrashloopBackoff. But first of all, what is CrashloopBackoff exactly in Kubernetes? When you have a pod running in your cluster and the pod crashes, by default, Kubernetes behavior is that it will try to restart the pod. This is to maintain high availability of your application, right? This is controlled by something called the restart policy of the pod, which by default is always, meaning when your pod crashes, Kubernetes will try to restart it. But what if the pod keeps crashing over and over? For example, you just made a new deployment to your code, but the code was buggy. So this code throws an exception during initialization. So now whenever your pod starts, the code throws an exception, and because of that, the container exits and the pod exits. This results in you being stuck in sort of a loop where your pod comes up, then pod goes through some issues, and then it crashes, and then Kubernetes will restart it, and then the same cycle repeats over and over. Now, Kubernetes doesn't immediately try to restart your pod always, right? In fact, with every crash, Kubernetes will wait slightly longer amount of time before it restarts your pod yet again. And this is called the backoff time. So for example, the first time your pod crashes, maybe after 2 seconds, Kubernetes restarts. Next time it crashes, it'll wait for 10 seconds and then restart. Next time it'll be 1 minute. Next time it'll be 5 minutes and so on, right? So this backoff time keeps increasing because Kubernetes is trying to give you more time to fix this issue. And since this backoff time is happening in sort of a loop where your pod starts and then crashes and then restarts, this whole thing is called a crash loop backoff. Now, the important thing is that crash loop backoff by itself is not an error. But when it happens, it usually indicates that there is some other underlying issue with your pod because of which it's constantly crashing. So you need to fix that underlying issue. So here in our case, maybe that was the faulty code. And so you need to now go and fix that faulty code, after which we will exit this whole loop because the next time the pod gets started, it will remain in the started state. And so we'll get rid of the crash loop backoff. So even in the case of this Prometheus alert about crash loop backoff, there must be some root cause. There must be some reason that this is happening, right? Whether we look at the cluster here or we look at the Prometheus alert, there must be a root cause. And the reason I'm showing you this Prometheus alert is because often in production environments, it is not practical for you to go inside a cluster and have a look at all these pods because maybe for compliance reasons, you're not even allowed to do that. But monitoring is always a more practical solution to get visibility into your infrastructure. So now I can again go to the terminal and point Holmes to my alert manager alert about this. And then from there on, Holmes can investigate what the root cause of this issue is. I'm going to supply it my alert manager URL. Runs here. Yep. And the alert name. CubePod crash looping. Now I can further narrow down by giving the exact alert, but here it's just one alert, so I'm just going to give it that. Okay, I think in this scenario, I got a pretty accurate root cause of what's going on. My application is actually running a container, which is running the stress testing application beneath it. And this application is commanded to consume about 350 MB of memory, whereas the maximum limit specified is 200 MB. This would obviously crash the container upon starting because the container is trying to consume more memory than allotted to it. So if I check out my deployment, it is indeed the case that my container is consuming more memory than it should be. But of course, this was a demo. In real life, the applications won't be as simple as this. You won't just be able to specify how much memory to consume. Rather, you have to monitor this kind of thing. And I want to show you one last thing. If you're using the monitoring dashboard from Robusta, the team that built HolmesGPT, you can get Holmes analysis right from the UI. So here's my inventory manager pod, which is currently in an alert state. If I go for AI diagnosis, Robusta 2 reaches out to HolmesGPT, which in turn connects to the LLM that I have supplied to it, and it gets all the investigation done and gives me back a proper response of what all investigation was conducted and finally what was the root cause that it arrived at. In this case also, we are getting a crash loop back off because the memory consumption of my container is too high compared to what I give it as a limit. So to resolve this issue, I either supply more memory to my pod by increasing the limits, or I reduce the memory usage to bring it within the current limits. That will help me get rid of the crash loop back off issue. Let's bring it down to 150, which is lesser than the limit. And give it redeploy. And this time it's running fine. So now my pod will not face the crash loop back off error again. But of course, when we are running real applications in production scenarios, it won't just be written somewhere that my application is consuming more memory than it should be, than its limits, right? We need to monitor for such things and we need to be alerted on such things. And once we are alerted, we need to troubleshoot these things so that we can find the root cause and fix it. And that is where Holmes is a total game changer. Because look how quickly it gave me the root cause. There is no doubt that AI tools like Holmes can save you a lot of time when you're troubleshooting issues in Kubernetes or Prometheus alerts. This is especially valuable during incidents when you receive a PagerDuty alert in the middle of the night and you want your problem to go away as quickly as possible. One thing I really love about Holmes is that it can work with multiple LLMs. I, for example, use GPT-4o, but it is a very simple process to point Holmes to use some other LLM, like for example Llama, or any of those LLMs provided by one of the cloud providers, for example AWS Bedrock. I do think that Holmes is not 100% accurate, especially when it comes to suggesting solutions. Sometimes the solutions felt slightly generic rather than very specific to my situation. But I expect this to get better over time as the tool matures and the LLMs mature. Holmes has many safeguards and rate limits in place to make sure it doesn't hurt your system in any way. It restricts the actions it can take, so you can be rest assured that it's not going to modify anything in your cluster. I personally hope to see speech to text as well. It's difficult to keep typing large prompts over and over. I also talk to the developers of Holmes and they tell me that in the next few weeks, we're going to have conversational abilities in the tool as well. So not only will you be able to point it to an alert, you would also be able to ask follow-up questions to Holmes. Finally, it is also great that Holmes is open source, but keep in mind that Holmes relies on some LLM to function properly, and that LLM might cost you some money. But overall, I'm very optimistic about Holmes and the future that AI brings for us. The sooner you start incorporating AI in your day-to-day workflows, the faster you get ahead of the crowd. So go ahead and give Holmes a try. If you found my video helpful, go ahead, give it a like and share it with your friends. Thank you for watching, and I will see you next time.